What you're seeing is the actual eggs and sperm traveling up to the surface of the water.
Wow.
So once they're on the surface and fertilized, then the planule will develop.
Yep.
But the underwater snowstorm, it's pink, red, orange. It is just spectacular.
Yeah, and it looks incredible, doesn't it?
Yeah. It's a beautiful show of nature.
Hello everyone, welcome to the latest edition of our Reef in Focus podcast, where we tackle all the big issues affecting the Great Barrier Reef. And joining us today is our Assistant Director of Reef Health, Surveillance and Innovation at the Reef Authority, Dr. Jess Stella. Jess, welcome.
Thank you, Lincoln. Good to be here.
Now, we're going to talk about all things coral spawning a little bit later on, but first, people might notice that that's not an Australian accent we hear on the other end of the microphone. Can you tell us, to start with, how did someone from Braintree, Massachusetts on the east coast of the United States find themselves in tropical North Queensland working for the Reef Authority?
Well, it was definitely not a direct path. So I did have a career before this. I went to uni out of high school as a pre-veterinary student. After many hours in pracs dissecting animals, I realized that's not really what I wanted to do for the rest of my life. I then became a travel agent and started traveling around the world, and that was when I first tried scuba diving. So I was in the US Virgin Islands on a holiday and tried the Discover Scuba course and just got in, and it was like, this is my home environment. Always wanted to be a mermaid as a kid, so I think that was my opportunity. But I was just really blown away with how different the environment is. You can move in a 3D manner. I mean, you can't do that anywhere else on Earth. And there are animals that are looking directly at you and wanting to interact with you, really curious. So I really felt like part of that environment. So yeah, I started going back to uni to get my marine biology degree, and brought me to an internship in Bermuda for a while. Yep. So I spent about a year there, and that was an incredible learning experience, how to do survey work and more scuba diving. And then I decided to come here in Townsville and go to JCU to finish my studies, and I've never left.
Wow. So from first coming across the beauty of coral reefs in the Caribbean, when was the first time you laid eyes on the Great Barrier Reef? We find with a lot of our guests who are all passionate reef guardians, there was one, I guess, pivotal moment where they first decided, this is where I want to be, this is where I want to spend my working life, protecting this incredible ecosystem. Yeah,
it was Wheeler Reef, so just off Townsville. I say just off because it was a 3-hour boat ride, but I was under the impression it was about a half an hour off the coast. So, but it was well worth it when we finally got there. I couldn't believe how different it was to the Caribbean and Bermuda. Bermuda has about 21 hard species of coral, so coming from that to the Great Barrier Reef with its 400 to 500 hard species of coral, it was just mind-blowing. I couldn't believe how lucky I was. So yeah, never wanted to leave.
Wow. And how long have you been?
18 years.
Wow, 18 years.
Yeah.
So from pre-vet student to travel agent to Caribbean drifter to tropical North Queensland, where you're now our as we said, Assistant Director of Reef Health, Surveillance and Innovation. What does that entail? Tell me about a day in the life of Dr. Jess Stella.
So I don't run around with a spy camera. That surveillance is a bit misleading in the title. What that means is actually surveilling the reef. So it could be doing aerial surveys or in-water surveys. What we do throughout the year, and especially leading into summer, is monitor environmental conditions. So looking at sea surface temperatures, if there's any increase in those, it might indicate a marine heat wave is happening, and that could put corals and a lot of other marine life under stress. We also look at the risk of cyclones impacting the reef any given summer, even though that's really hard. They're quite random. If we have a La Nina year, which is often associated with heavier rainfall, we might have flood plumes affecting the reef and carrying sediments and nutrients down to the reef. So it's looking at kind of the risks of all of those things happening, and then formulating well, if this does happen, what are we going to do about it? We can't stop any of these things. We can't go out and protect a reef from a cyclone or stop bleaching once it happens. So that surveillance part comes in, and we actually monitor the health of the reef to see how it fares through each of these events, which is really important because when we're looking at the overall resilience and health of the reef, how it manages these different impacts, and sometimes they happen all at once, but how it manages to either resist impacts from those environmental disturbances or has to recover from them. So that could be, recovering from bleaching, which bleaching is a temporary state, so a lot of coral colonies can actually just recover their color. Or if there's a cyclone or a more severe bleaching event and corals die, then how the reef actually repopulates those corals back on.
And we know that they are incredibly resilient on their own, aren't they? They have, or it's shown over the years that they are able to bounce back from these types of disturbances if conditions go back to normal, if you like.
Yeah, exactly. So they have a narrow thermal tolerance range. They have different life strategies. So there's 400 to 500 species of coral. They have different rates of growth. So some grow really fast, but they're also really susceptible to damage. Crown of thorns love to eat acropora corals, so they're particularly susceptible to predation. Boulder corals that are more resistant to bleaching and cyclonic waves, they grow a lot more slower. So you have those different growth rates, different reproductive strategies. All in all, that gives us a really good genetic pool out on the reef. So to draw from, kind of getting the best of the best would be ideal. Things that are more robust to disturbances over the long run and maybe can grow fast as well. So that kind of adaptation is probably happening all the time.
Yeah. And looking more broadly, I guess your role relates to reef health as a whole. And at the moment, we're seeing, some really positive signs of reef health that gives us all a lot of hope. And that's coral spawning, which is arguably the most incredible spectacle on the Great Barrier Reef. Can you tell us a little bit, or why is it so magical? What is coral spawning?
So coral spawning is the biggest reproductive show on Earth. There's many other names for it. But
would you like to elaborate?
It's business time for corals. Yeah. So they can't move around and go to bars and meet potential mates. They're stuck to the benthic substrate.
Yeah.
So they do broadcast spawning, a lot of species. So they throw their eggs in their sperm bundles up into the water column. They're yellow, pink, orange, beautiful displays of color. They float up to the surface. And that is when the real magic happens. So they meet other sperm or eggs of the same coral species, and hopefully fertilization brings about a new coral larvae. And we have the next generation of corals coming back on the reef.
Are they visible? How big are we talking?
Yeah, they'll usually form a slick at the surface of the water, which is pink or orange. You'd know it because it smells, it has a very distinct smell, coral spawn. Yeah, so you can see it from the air. But yeah, people will definitely comment on the smell.
Yeah, okay. And how do they know, what cues them or what instigates them to spawn all at the same time? How do they know when conditions are right?
Yeah, right. So they can't talk to each other. There's no Tinder for corals, and they use chemosensory abilities. So without eyes and brains and mouths, they smell. So they can smell cues in the water.
Yep.
They usually will spawn 2 to 6 nights after a full moon, and it's usually going into summer, so right before summer, and about 4 hours after sunset, so under the cover of darkness. That keeps predation down a bit because during the day, all the planktivorous fish are forming their wall of mouths, as we know it.
Yeah.
They'll eat every bit of plankton that comes onto a reef. So any little particle is up for grabs. So they do it at night. So when the planktivores are sleeping, they'll go ahead and spawn.
Yeah, okay.
Yeah.
And is that what we can see when we see that incredible vision of those fluoro pinks and all sorts of things? Are they the larvae that you were talking about?
What you're seeing is the actual eggs and sperm traveling up to the surface of the water.
Wow.
So once they're on the surface and fertilized, then the planule will develop.
Yep.
But the underwater snowstorm, it's pink, red, orange. It is just spectacular.
Yeah, and it looks incredible, doesn't it?
Yeah, it's a beautiful show of nature.
And you mentioned that it was more prevalent during summer, but does it happen year round?
It does. Some species will spawn every month. There's some species of coral that brood their eggs, so they actually hold on to them, don't release them. They're not broadcast spawners, so they don't put them up into the water column.
Yep.
Across the latitudes of the Great Barrier Reef, because it is so vast, it's the largest coral reef ecosystem in the world.
Yeah.
It's not all happening at once in all of those locations. So corals are adapted to local conditions.
Yeah,
so
okay.
their temperature.
So there's no
regime
method to it really. You're not expecting a certain area to start before another, or you are?
The rule of thumb is the inshore reefs would usually start a month before. So the full moon, probably going into summer, it would be end of October.
Yeah, okay.
And then end of November, early December, the mid and the outer shelf reefs would spawn. So there is a little bit of difference. But the inshore reefs can warm up quickly too. So that rapid rise in sea surface temperatures to about 27 degrees, the full moon, those are the cues that let the coral know that it's time to get your eggs ready and ready to go.
Yeah, okay.
Yeah.
And for those of us in the water looking for it, is any more spectacular than the other? Is it more spectacular inshore or out on the outer reefs?
It's just, it's one of those things you have to be at the right place at the right time.
Yep.
The first time that I witnessed it, we were on a boat just over on Yimbinin on Magnetic Island.
Yep.
And most of the divers, as soon as the sun went down, they're chatting and got ready, all geared up and, pushing their way through people to get in the water.
Yeah, okay.
And friend and I sat back, no hurry. And they were just coming back from their dive when coral started to spawn. So we got to go in and we had, the whole place to ourselves.
Yeah, wow.
Because their dive was over. So, it was pretty cool, pretty special.
Well, you have the inside knowledge, I guess. You know what to look for and know when it's coming. Can we look back a little bit further? When, I guess from a scientific point of view, when did we start noticing that this was happening on the reef? When and where did we first discover coral spawning?
Just off Townsville. So
Yeah, wow.
Magnetic Island, early 1980s. So researchers from JCU.
So it's only, I guess, quite recent in the grand scheme of things that we realised this was happening.
Yes.
Yeah, okay.
Yeah, not very long at all. There's still so much that we don't know about it, but just being able to observe that, multi-species synchronous spawning, I think is what they called it at first.
Yep.
Just being able to witness that and document it. I mean, I'm sure it's been going on for a very long time, but being there at the right time and documenting that, it just right off here in Townsville. So
Unbelievable.
Very lucky.
And I imagine it never gets old seeing the colours in the water and, the reef really sort of come to life of a nighttime.
Yeah, I mean, I'm, maybe I have a different take on it because I do appreciate what coral spawning is and what it symbolizes for the reef and that, regeneration in a time of genetic mixing. So if adaptation's going to happen. My favorite bit is watching all of the invertebrate creatures come out to eat the eggs because they're really
that's your
nutritious.
Area of expertise, right?
Yes.
Okay.
Yeah. So.
All right. Well, we won't get too bogged down on the invertebrates.
But it is a smorgasbord.
Yeah.
So it's feeding a lot of animals that depend on that, supply of food.
Yeah. Wow.
And they're kind of swamping the predators by producing so many eggs and sperm at the same time. That's why all the species do it at the same time.
Yep.
So some of them will survive. So the predators can take their fill and there'll still be millions of eggs to be fertilized.
Okay. So it really is just finding that balance and overcoming the odds, if you like.
Yes,
Yeah,
exactly.
Okay.
Yeah.
Wow. So touching on your area of expertise, Jess, we'll get into the invertebrates a little bit with a limit.
Great.
How is that all connected? You mentioned that while they, I guess, flood the environment, if you like, to make sure there's a chance of them surviving, how do those invertebrates that live in the coral also depend on coral spawning? How is it all linked together?
That's a really good question. And as we know, nothing goes to waste on coral reefs, most ecosystems, but coral reefs particularly because things can float around in the water. Corals that produce egg bundles are often reliant on little invertebrates that live within their branches to protect them, clean them. So sometimes along with egg bundles, they produce these little fat bodies that attract invertebrates to come settle in the coral and guard them. So there's a whole community going on there. Some, unspoken words of communication, probably through sensing smells and things like that. those eggs and sperm and the planula themselves, once they develop, really nutritious. So, and they're so tiny that a lot of things can eat them. So everything does eat them.
So when we talk about the Great Barrier Reef is the most complex, or one of the most complex ecosystems on the planet, there's no better example, right, than coral spawning and the relationship with these invertebrates.
Yeah. So, I mean, corals are invertebrates themselves. They're one of the cornerstone habitat forming species. So, to say that they're the most important would be...
well, you're a little bit biased.
I am a little bit biased, but they are the most important because they form the habitat for everything else to live. So symbiosis is really one of the mechanisms why coral reefs are so diverse. So being able to live on coral, in coral, some invertebrates burrow into the coral, and that connectivity of resources between what the coral's producing and the food going out, it's all part of the food web that keeps coral reefs nutrient free as well as really healthy. So,
and when you say symbiosis, it's really just about finding that balance. That's what you mean?
Yeah. So, I mean, corals obviously have a symbiotic relationship with tiny algae that live within their cells, and they're called zooxanthellae, and they can photosynthesize. So they produce complex carbohydrates out of sunlight, and they feed the coral with that. Corals can also feed themselves. They have tentacles, so usually at night they'll pick out small particles of plankton from the water, probably other coral species, eggs and sperm as well. So that they're really opportunistic. Everything on the reef is pretty opportunistic with getting a meal whenever they can. Yeah. So nothing goes to waste.
And leading into the summer, I guess there's no better way to look at the health of the reef. Obviously, coral spawning is a sign that the reef is doing well, but there's certain alarms or warnings that you were saying before that we have to look out for. And can you elaborate on that a little bit further? What are some of those signs that we're looking for?
So what we would look for typically in going into summer and even throughout the summer, because it becomes kind of a daily task, is looking at the sea surface temperatures. If they're increasing, how warm they're becoming, how rapidly they're increasing, as well as chance of cyclones coming. I mean, cyclones can have a particularly devastating effect on a patch of reef or a narrow tract of reef. And flood plumes can lower the salinity and carry a lot of nutrients from the land, from farms, but also different types of soils and metals into the water column. And those can cause coral bleaching, coral disease. They can bring sediments that'll smother corals. So they do deal with a lot of different impacts. And what we try to do is at least get a handle on what those impacts are, what we can do about some of them, because there are some things that the Reef Authority can't actually directly manage. So for the largest threat, which is climate change, we can't limit emissions for the entire globe. That is going to require a concerted global effort. What we can do is enforce our compliance on marine park zoning laws, making sure everyone is in the right spot when they're fishing, and addressing illegal fishing, as well as controlling the crown of thorns starfish, which loves to eat coral.
And just going back to that before, obviously those external impacts or those pressures will have an impact on coral spawning if the water gets too warm or if there's too much sediment, if there's a flood of fresh water or extreme weather events. This would all impact coral spawning, correct?
We haven't seen many impacts on coral spawning itself, because maybe it happens in going into summer, so before things get too hot or windy or rainy. It could affect their settlement success. So when the planula are coming back to settle on the reef, even when they start to, so they look like an upside down jellyfish when they find a spot that's suitable on the reef, and then they start budding and producing clones of the polyp. Then you have a juvenile coral within a few years, and then a mature coral. So there's a lot of stages it has to survive in order to become an adult mature coral, also participating in reproduction. So any of those stages, if it's settling back onto the reef and there's a marine heat wave or a cyclone,
It affects all of these things.
Yeah, exactly. It would probably lower the survivorship of those.
When is a coral classed as mature? Is there sort of a 4 or 5 year period when they'll start spawning, or it'll start spawning itself, or does it depend on the variety of coral?
Really depends on the species, yeah. So Acropora is one of the most widespread coral, the genera across the Great Barrier Reef. They're really fast growers. They can reach maturity in 5 or 6 years, where other ones, kind of like the boulder corals, which are they grow to an amazing size, bigger than this room probably.
Really?
Yeah. But they might live for 500 years or 1,000 years. So it takes them a lot longer to get to that size. They're quite robust. So they all have different life strategies. So some grow fast, die fast, really susceptible to bleaching or breakage, which Acropora is. It's also one of the preferred coral species of crown of thorns starfish.
Oh, I thought you were going to say invertebrates.
Nope.
Sorry.
Although starfish is an invertebrate.
So looking at those different types of corals, particularly the ones inshore to start with, how does the Reef Authority manage and protect those on a broad scale?
Well, the reef is huge, as I mentioned before, so it covers 2,300 kilometers of coast. There's over 3,000 individual reefs, so obviously we can't be everywhere all the time. We have zoning rules, so those different zones will tell people what activities they can do in each of those zones. So some areas are not open to fishing. Some areas are only open to fishing certain times of year or to commercial fishing. So by partitioning the marine park, users can have a wonderful experience with what they want to do. If it's snorkeling or diving, they know that a commercial trawler is not going to come right through their dive patch. So we really partition that, and it also helps to protect certain parts of the reef so that the fish and the coral can reach a really good size and produce a lot of larvae, and that tends to overflow into the other parts of the marine park where fishing is allowed, say. So there's this overflow of fish and coral larvae from those protected reefs. So really important to have them because they lift up the stocks of the fish that people are really interested in targeting, and keeping that connectivity of the reef, a connection of healthy reefs, really does help with the whole of the ecosystem health.
So looking at the success of marine park zoning, even though I guess it's a little bit outside your area, it's all connected and we're really starting to see the results of that, if you like.
Yeah, it does take a few years, more than a few, to see those effects of, say, our green zones where fishing is allowed, and blue zones where fishing is allowed. So there have been lots of different studies that have shown that green zones have a higher biomass of target fish species than the blue zones, but they also export larvae into those blue zones. So it's really important to have those different refugia for those species to be able to grow to a large size and reproduce. And it also helps the fishers get the fish that they want.
So from that, it shows, I guess, how successful zoning or marine park zoning is within the marine park. Can you just elaborate? What's the difference between a blue zone and a green zone?
Sure. Green zones are marine national park zones, so there is no extractive activities allowed there. So no fishing, photography, diving, all allowed. The blue zones are open to fishing. So those two different zones can look quite different to each other in terms of the fish biomass. And those green zones are really important because research has shown that they not only protect the fish species that live in the green zones, but they also export larvae from those fish and coral into blue zones.
Which regenerates.
Exactly.
Yeah, exactly.
Yeah. More fish for the fishermen.
And it's incredible, I guess, that these marine park management practices can have such a positive impact on a complex ecosystem like the Great Barrier Reef. It's quite hard to explain, but we're seeing these positive results from things like marine park zoning.
Yes. The marine park zoning that we have now was developed and rolled out in 2003 to 2004. So we're coming up on 20 years of that zoning plan, and it has been very effective at protecting areas from extractive activities like fishing, but it still allows multi-use around the entire marine park. So people can always find a spot where they're allowed to do what they want. I mean, with limits for sure, but fishing, just keeping those things separate so that we have a network of healthy, connected reefs that are still, transferring larvae, and we get, greater genetic biodiversity along the Great Barrier Reef, as well as opportunities for adaptation. So hopefully with climate change, although it's happening very fast, adaptation can happen where corals can develop new gametes that are more thermally tolerant to the temperature rises.
So whether you're out there fishing, swimming, snorkeling, scuba diving, whether you realise it or not, we're seeing these benefits sort of firsthand at a time when the reef is under, admittedly, a lot of pressure.
Yes, absolutely. There are a lot of marine parks in the world's oceans, but hardly any of them are our size, for one. And it's also really important that you enforce that marine park zoning. So if you make rules and don't enforce them, no one's going to follow them. So we do have a compliance team that actually enforces those. They're out in the water, they're in the air, they're watching as many corners of the reef as they can, make sure everyone is doing the right thing in the right spot.
Yeah. And the beauty of the incredible people involved within the Reef Authority is they're not only passionate reef guardians, but they're out there using the reef themselves.
Yes,
like
exactly. You. Yes. Yeah. We all love the reef. I love being able to go out and see the reef. I mean, I would do that more often if I could get out from behind the desk. But it's really important to stay connected to what we're trying to aspire to, and that's protecting the reef for future generations. So unless we see the reef and fall in love with it, I mean, you don't protect what you don't know or you don't love, right? So we want people to feel that sense of stewardship over the reef. And
like you said, what advice would you give to people to help protect the Great Barrier Reef into the future?
I think the first thing, if you haven't seen it, get out and see the reef. Bring your children, bring your friends, relatives. It's a beautiful place. It is so varied. There are so many different things that you can do on the reef. I mean, you can find a secluded island, a beach to yourself, go fishing, go scuba diving. There's lots of ways that people can actually protect the reef, even at home, and that's talking about climate change and what those impacts might bring, not just to the reef, but to other ecosystems around the world. And just building that real sense of stewardship. It's a global icon, but it sits in Australia. It's a World Heritage Site, and we have custodianship over that. So it's really important that we look after that so that all the future generations can enjoy it too.
And if someone who grew up in Boston falls in love with the reef, anyone can do it.
Exactly.
Always a pleasure, Jess. Thanks very much for joining us.
Thank you, Lincoln.